We're going to get started here in just a few minutes. Let me go ahead and share my screen, make sure everything is okay on all the different channels too. I'm hoping that the audio is okay on all of this. I listened to last week's live stream, like the playback, and I don't know, something was happening. Oh, okay. Okay, great. All right, sorry. I unmuted my YouTube for a second just to make sure that the audio was okay. Okay, looks like we're good to go on YouTube and Facebook. I'm not doing Instagram today. Um, I I realized that I needed more followers on Instagram and I do not have that yet. So if you don't follow me on Instagram, that would be great if you could. They have a limit or there are limitations to what you can do on Instagram without a certain number of followers. So that's just where we're at today, and that's fine. All right. We are going to go ahead and get started pretty soon. Um, I have here, I'm sharing my screen. So we've got our live stream rules and community guidelines over here. Also, some ways to support me if you are interested. Excuse me. You can subscribe on YouTube. You can follow my Facebook page. All of that is going to be in the links in the description. Whether you're watching this on YouTube or Facebook, I have all of the links in the description there. So you can follow me on all the socials. My Instagram is in there, as well as TikTok. I have not started to look into doing live streams on TikTok. I know that they typically favor the vertical format, and obviously, like this is a horizontal layout here, um, consistent with a typical YouTube video. So that is where we're at with this for today. But what we're going to be covering is in pre-algebra, we're going to be going over the midpoint formula and the distance formula. Since we learned about Pythagorean theorem last week, those two are, well, the distance formula is directly related to that. And then we'll talk about the midpoint formula as well. And then for Algebra 1, we're going to be doing more solving quadratics, but we are going to be doing it in two different ways, taking the square root and then using the quadratic formula. So let's go ahead and jump into it. Please feel free to comment if you would like. Whoa. Actually, hang on just a second. Let me make sure I have my chats up too. Sorry. Okay. We're good there. I'm streaming this through Restream today, so that I can stream to both channels. I haven't had enough experience with the chat yet to see what that looks like. So, like it's supposed to compile it all into Restream. So we'll see. If you're here, please say hello. That would actually really help me to see what the chat looks like. Just say hi in there, whether you're on YouTube or Facebook. And that way I can see where I can find that chat, because that would be really helpful for me. Like there's only so much that I can do on my own when I'm just doing these test runs and things. So, all right. Anywho, let's go ahead and get started. We are going to start with our pre-algebra midpoint formula. Get a different color pen here. So, I've got this, this is all from Kuta software, not this one. That's not the one that we're using today. This is all from Kuta software. They have free worksheets there. So you can go there, go to the pre-algebra section, and then look for the midpoint formula. These are just problems that I copy pasted from those pages. But this in the box here is our midpoint formula. So a midpoint is like we see on the graph here. If we're looking at these 2 points, this is one point and this is the second point, and we want to find the middle, right halfway between those 2 points. That's what we're talking about with the midpoint. So basically what we're doing with the formula is we're taking the two x values and averaging them, or finding the mean, dividing by 2. We add them up and then divide by 2. And then we do the same thing with the two y portions of each of those points. So we're going to add up the two y values, divide by 2, and that will give us the average, and that will give us the midpoint, the exact coordinate of that point that is halfway between those two endpoints. When we have a graph like this, you can actually use slope to find this as well. So we can visually find the midpoint with this particular graph, and we can mathematically find the midpoint. So what we're going to do, I'm going to show you with slope first. I'm going to take a look at, I'm going to start down here with this bottom point, and we are going to figure out what the slope is between this lower point and this point up here. So if we go 1, 2, 3, 4, 5, 6, so that's 6 units up. And then if we go 1, 2, 3, 4, that's 4 units to the right. Now, these are both even numbers, so it makes it very convenient for us. What we can do is we can just take a look at half of each of those. So half of 6 is 3. So if we go up 3, 1, 2, 3, and so now we're kind of stopped right there. That's not, I don't really want that to look like a point. That's just sort of like my stopping point. And then if we take half of our run, 4, which is 2, we go over 1, 2, and then that point right there should be our midpoint. Now, let's show how to do this mathematically. So first, what we have to do is figure out what our points are. Now, when you see these little 1s and 2s that are by the x's and y's, all that means is that this is the x value from the first point, and this is the x value from the second point. This is the y value from the first point. This is the y value from the second point. That's all that is really indicating to us. So I'm going to, and it does not matter which one you call point 1 and point 2. We could label this one as point 1 and this one as point 2. I could switch those. In this particular formula, it does not matter, especially if you mix up, if you put the x's in a different order or the y's in a different order, because we're adding, and with addition, we can add numbers in any order. However, I would caution students to keep things consistent, because with other formulas that use like x1 and x2, y1 and y2, it does really matter with the order that you put things in. So I don't want you to get, off on the wrong track. So we're going to call this point 1. So it looks like this point is at 1, 2, 3, 4, 5, -5, -2. And this point is at -1, 1, 2, 3, 4. -1, comma, +4. Okay, so this is, I'm going to try to color code this here. This is our x1 and our x2, right? So, this is our x2. So the first number in each of our points are the x values. So this is the x value from our first point, and this is the x value from our second point. And then in the green, we're going to label this y1. So this is the y value from the first point. And then in blue, we've got y2. This is the y value in our second point. And now we're just going to go ahead and put those into our formula. And notice that this is in parentheses. It's got a comma in between. And that's because the average of the x's is going to give us the x value of the midpoint. and the average of the y's is going to give us the y value of the midpoint. So x1 is -5 plus x2 is -1 over 2. And then for our y's, y1 is -2 plus y2 is +4 over 2. And so we're just going to solve each of those. So -5 plus -1 gives us -6. So actually, I'll go ahead and write it all of the steps out really clearly here. And then -2 plus 4 gives us 2. So we've got 2 over 2. And now we're going to simplify each of those. -6 divided by 2 is -3. 2 divided by 2 is 1. And let's see where our midpoint is that we found visually. So we've got 1, 2, 3, -3, and then up 1. So that is the midpoint at -3, 1. All right, let's do that same thing here with problem 3. And as you can see down here with some of these other problems, we don't have the graph at all. Now on this graph, we might be able to visually see where this is. Again, we can use that slope, rise of 1, run of 1, 2, 3, 4, 5. So because these are odd numbers, we are going to have a midpoint that doesn't land on an integer. So let's go ahead and use our formula for that. So I'll call this point 1. So this is going to be, this is at 0, 1. And this is going to, hold on, let me label that point 1. And this will be point 2. And this is 5, 2. And then let's go ahead and average each of our x's and y's. So our x's are 0 and 5. And our y's are 1 and 2. So we're just taking the average of each of those. Now, 0 plus 5 is 5. So 5 over 2. 1 plus 2 is 3, so 3 over 2. Now, you may want to leave them like that. You may want to leave them as improper fractions since 5 and 3 aren't evenly divisible by 2. We could write them as decimals. We could write them as mixed numbers. So as mixed numbers, 2 goes into 5 2 times with 1 left over. 2 goes into 3 1 time with 1 left over. So that would be how we would write this midpoint as with mixed numbers. Or we could write them as decimals. So we would have 2.5, 1.5. So that's how we would look at that as decimals. And then let's go ahead and label that midpoint on our graph here. So we've got 1, 2, we want to go 2.5. And then we want to go up 1 and then just another half. So it looks like our midpoint is right there at 2.5, 1.5. All right, let's go ahead and go on down here to these. Now we'll do this first one. For number 11, we will find the midpoint. And then I also want to show you, a lot of times students get really hung up on if they are given the midpoint and one endpoint and are asked to find the other endpoint. So we'll do with that one, we will find the other endpoint on this one. That's not how this problem was originally written, but I want to show you how to do that just in case. And let me get this work out of the way a little bit here. Okay. Alrighty, so then for our midpoint here, we're going to take those x values and average them. So 5 plus -4 over 2. And then we're going to take those y values and average them. 1 plus -12 over 2. 5 plus -4 is 1. So that gives us, I'm going to rewrite it to the side here. That gives us 1 over 2. And then 1 plus -12 gives us -11. So we get -11 over 2 for that one. So that would be our midpoint. And again, we have odd numerators, so those aren't going to go in evenly. So I'm just going to leave these as fractions, and a proper fraction and an improper fraction. Okay. Now let's take a look at 13. We need to find, so let's say that the question is asking us to find the endpoint. And then they're telling us that -9, 8 is the midpoint and 0, -11 is the endpoint for this graph. So let's kind of visualize that just a little bit. Let me just do a quick little sketch of a graph here. Negative 9, 8 would, let's say, is negative 9 here and then 8 here. So it's going to be like something like that. And then 0, negative 11, so 0, and then negative 11 down here. That's going to be one of the points. So remember, this is the midpoint, and this is one of the endpoints. So we know the line is like this, but it's going to continue here. So our other endpoint lives somewhere out here. So that's what we're looking for. We want to know what is this other coordinate for this endpoint. Hopefully that's not too there's enough contrast there to see that, but hopefully that will make sense once we get down to using our formula. So remember, our formula is x1 plus x2 over 2 equals midpoint of x, right? So we'll just kind of write it like that for now, comma, and then y1 plus y2 over 2 equals the midpoint for y. So I'm just going to write it just with the y sub x and sub y to show that that's the midpoint, the x value for the midpoint, and the y value for the midpoint. Now, what pieces of the puzzle do we have? Well, we have mx, and then we have one of those endpoints. So I'm just going to call this x1. And then we also have the midpoint, the y part of the midpoint. And then we also have the y portion of the endpoint, the first endpoint. So let's sub those numbers in. So instead of mx, maybe I shouldn't erase it. I'll just rewrite it down here. So x1, we've got 0. We don't know what x2 is yet. That's what we're trying to find. But we do know that if we divide it by 2, it will equal negative 9, right? So we're plugging in the pieces of the puzzle that we have, that we know. Same thing with y. We have y1 is negative 11. We don't know what y2 is, so we're going to leave that as y2. But we do know that when we divide the two of these added together, it's going to equal 8. Okay, so this one, you do have to kind of write it out, each one out as its own equation. And then we're just solving for x and solving for y. We're solving two separate equations here. So let's go ahead and solve for x first. We're going to multiply both sides by 2. That's going to cancel out with our denominator here, leaving us with 0 plus x2 equals negative 9 times 2 is negative 18. And 0, really, it just is a placeholder for nothing. So we really don't even need this part. So now we know that that endpoint, the x portion of that other endpoint is negative 18. So we're going to have negative 18 for the x portion of that. And then let's do the same thing here for our y. We're going to multiply by 2, multiply by 2. That's going to cancel out right here, giving us negative 1 plus y2 equals, that's going to give us 16. All right, and then we do have one more step for this one. We need to add 1 to both sides. So y2 equals 17. So this is going to equal 17. So our other endpoint is at negative 18, 17. And looking back at our little sketch of a graph here, let me actually see if I can move that out of the way. There we go. Looking at our sketch here, that kind of tracks with what we were saying. We know it's going to be further out. For the x value, we're going to be going more negative. So we'll be at negative 18 out here. And then for our y, we would be much higher. So we would be at a higher positive value. So at positive 17. So that is how you find the missing endpoint when you're given a midpoint and one endpoint. Okay. Checking in on the chat. If you're here, please say hello. I would love to see who's here, see how it shows up in the chat on Restream, which is what I'm using to stream for tonight. Okay, let's go on to Again, I did not use this website. This is all from CUDA software. Now let's talk about the distance formula. So whenever I show this formula to students, they kind of their eyes get really wide because it looks really complicated, but it is related to the Pythagorean theorem, which we talked about last week in last week's live stream. So this is basically just a way to find the distance between 2 points. Now, when our 2 points are at a diagonal like this on the coordinate grid, then we really can't count the squares. Let's say we had a point here and a point here, and we want to know the distance between these 2 points. We could pretty easily just count the units between these 2 points because it is vertical. Same thing with a horizontal line. If we have point here and point here, we can find the distance by just counting those units between the 2 points. But when they're diagonal, we can't just count. The squares don't count as one unit when it's going through diagonally like this. So one way that we could do this is by setting up a right triangle and then using that a squared plus b squared equals c squared to help us. So we could call this a, this would be 2 units long. This is b, this would be 1, 2, 3, this would be 4 units long. And then we could set up that Pythagorean theorem and find the distance of c, which is the hypotenuse and that slanted or diagonal part of the triangle. Or we can use the distance formula. So again, we see in the distance formula that little sub 1s and 2s for both our x's and y's. So for this one, it does definitely matter the order because we're subtracting. So with subtraction, we can't just flip around the numbers. 5 minus 4 is not the same as 4 minus 5, right? So we can't switch them like we can with addition. So let's go ahead and label our points. It does not matter which one is point 1 and point 2, but it does matter once you assign point 1 and point 2 to keep them consistent. So I'm going to call this one point 1. I'm going to call this one point 2. And point 1 is at 0, 1. And point 2 is at 2, 1, 2, 3, negative 3. Okay? And now let's go ahead and plug that into our distance formula. So distance equals the square root of, let's go ahead and label our points as well. So this is x2 because that's the second point and that's the x value from that second point. This one is x1, the x value from the first point. This is y1. And then in blue, we're going to do y2. Okay. All right. So x2 is 2 minus x1 is 0. And then we're going to square that. And then in our second set of parentheses, y2 is negative 3. And we're going to subtract y1, which is 1. And then we're going to square that. Okay. All right, so now we're just following order of operations. We got to do what's inside the parentheses first. So 2 minus 0 is 2, plus negative 3 minus 1 is negative 4. I'm going to leave this one in the parentheses just because I want that negative to be enclosed in the parentheses, signaling that this is negative 4 times negative 4 when we go to square it. And we're going to take the square root of all of that. All right, so now let's do our exponents. 2 squared is 4, plus negative 4 times negative 4 is positive 16. So we've got 16, and we've got the square root of that. And then 4 plus 16, we want to go ahead and complete whatever is inside that radical. So 4 plus 16 is 20. And the square root of that. Now 20 is not a perfect square, so this is where we would want to simplify that perfect square. So I'm just going to write that over here, 20. We're going to use the factor tree is 2 times 10, and then 10 is 2 times 5. We do have one group of 2s. If I started to say factoring, if simplifying square roots or cube roots is something that you want more support with, I have a ton of videos in my on my YouTube channel, both long form videos and shorts. So check those out if you're if this part was a little bit confusing for you. But as we've simplified the square root of 20, we get 2 square roots of 5. So that is the distance of this line. That is the length, if you will, of this line in the units on the coordinate grid. Okay, great. Let's go ahead and do this next one. How are we doing on time? I feel like this one is taking a little bit longer than I was anticipating. So we'll try to speed things up for these last couple of problems. All right, for this one, I'm going to call this point 1. This one's point 2. And point 1 is at 1, 2, 3, 4, 5, negative 5, 1, 2, 3, 4, negative 5, comma 4. And point 2 is at 0, comma negative 5. So again, I'm just going to label my points. I find that very helpful, especially when we're first learning how to do this. And distance equals the square root of x2, 0, minus negative 5. So whenever I'm subtracting a negative, I go ahead and turn that into a plus just to simplify it a little bit. And then for my y's, I've got y2, which is negative 5 minus 4. And we're going to square that. Okay, so then again, inside the parentheses, 0 plus 5 is 5. And that's squared. Negative 5 minus 4 is negative 9, and that's squared. We're going to take the square root of that at the end. 5 squared is 25, plus 9 squared, negative 9 squared is going to give us a positive 81. I don't know, hopefully you can kind of see how this relates to Pythagorean theorem, because essentially 5 is the distance between our x values. So that would be like one of those, either A or B, one of those legs of the triangle. And 9 is the distance between, for the other leg of the triangle, it's the distance between the y values. So that's, kind of where this formula comes from. And then when we add up 25 plus 81, let's see, that gives us 106. Square root of 106. Not a perfect square again. So we're going to just do a little quick factor tree of 106. So I know 2 can go into that 53 times. Can 53 be divided by anything? This might be it. This might be just the square root of 106. So since we wound up with prime numbers here, then that is going to be our distance for that one. Okay. And then of course, down here, I'm not going to go through just because we're I don't want this one to be too long, but I would call this point 1 and point 2. And this would be x1, y1, and x2, y2. And then we would sub each of those numbers into our distance formula and figure out the distance. We just don't have a graph for these last two problems on this page. All right, great. Okay, let me know what you thought of that. Leave me a comment if you're here. I would love to hear from you. And we're going to go on to algebra in just a moment. Let's see what we have down here. Okay, we're going to start with solving by taking the square root. Okay. All right, let's go ahead and get started on this one. So when solving for whatever our variable is, I was going to say x, but sometimes it's not going to be x, but that's okay. When solving for a quadratic like this, a quadratic being when we do have a squared variable somewhere in our equation, then sometimes it makes sense to solve by taking the square root. So in this first problem, we've got k squared equals 16. And typically, if we are solving a quadratic, we would want everything to be over on one side and we want the whole expression to be equal to 0. So students might see this and go, okay, well, I know that this 16 has to be over here on this side, and we would get k squared minus 16 equals 0. And that's fine. You can totally do it that way. And then from this point, you would hopefully see that this is a difference of two squares, and factor and then solve each of those factors by setting them equal to 0. So that is one way of solving these types of problems. However, we can just use it just as it is with k squared on one side of the equation equals 16 and just simply take the square root of both sides of the equation. So what that does, the square root and a square, those are inverses of each other. So, okay, we're fine. So those cancel each other out. So that square root and that squared cancel out and give us just k. And so then that equals, since 16 is a perfect square, this is a great method to use for this particular problem because the square root of 16 is 4. However, when we are solving for equations, we need to consider the fact that that 4 could be positive or negative. So we want to solve this as plus or minus 4. So this is just a shortcut way. This plus minus symbol in front of this number is a shortcut way of writing that k can equal positive 4 or k can equal negative 4. And let's think about that. If k equals negative 4 and we want to evaluate this equation, k squared equals 16. If we substitute in either of these numbers, 4 or negative 4, we will get 16. So 4 squared does equal 16, and negative 4 squared also equals 16 because that negative times negative is going to cancel each other out. So that's why when we are solving equations and taking the square root of both sides, we need to include that plus minus symbol in front of the numbers. All right, let's take a look at another one, 25. So we've got x squared plus 8 equals 28. So just looking at this, neither 8 nor 28 are perfect squares. So what we could do is subtract 8 from both sides, and we get x squared equals, and then 28 minus 8 is 20. Now again, we still don't have a perfect square. However, we can still use this method. We can do the square root. We can square root each side of the equation. What that does is it cancels out that square for x, and we get x equals plus minus the square root of 20. Now, the square root of 20, I think we just did this one on the other page. We're going to simplify a little bit. So 20 we can break up into 4 times 5. And then 4 we can break up into 2 and 2. So that's our pair of 2's right there. So we get 2 on the outside of the radical and then 5 on the inside of the radical. So again, that plus minus just signifies that this could be a positive 2 square roots of 5 or a negative 2 square roots of 5. So then that is both of our solutions for this one. So both of these problems that we've solved so far have 2 solutions. All right, let's go down to this last problem that I have here. Now, typically we would want to get n squared by itself. However, 16 is a perfect square and so is 49. So if I divided by 16 in order to get this by itself, I would get n squared equals, and then this it doesn't go in evenly. So we could leave it like this and still take the square root. Then we're going to run into rationalizing and things like that. If we took the square root of this, we would get the square root of 49 over the square root of 16. So n equals square root of 49 over the square root of 16. And then we can simplify each of those. Because they are both perfect squares, we actually aren't going to have to run into rationalizing on this one. we would get n equals 7 over 4. Square root of 49 is 7. Square root of 16 is 4. But then, of course, we don't want to forget that plus minus. Or the other way we could have solved this problem is simply taking the square root from the beginning, because all of these are perfect squares. So the square root of 16n squared would be 4n, and then the square root of 49 would be 7. And then we can divide by 4 in order to finish solving for n, because we do want n by itself. So that would give us 7 over 4. So we still, plus or minus 7 over 4. That is where that comes from. This would be plus minus as well, but since we're dividing both a positive and a negative, it would change the positive to a negative and the negative to a positive. So you don't have to worry about that too much. We just know that this end result would have to be plus minus 7 over 4. All right, so that is solving with square roots. So pretty simple on that one. Let's go down here to solving by quadratic formula. Now, this one will take up a lot of space on your paper. This one will take up a bit more time. If you have the option of solving, like by using factoring or by using the square root, like I just showed you, I always suggest using those other methods first, but some are just not factorable, or they just don't work with the square root. So especially with trinomials here. So quadratic formula will always work. It's just a little bit more work to get there. So let's go ahead and talk about this quadratic formula here. So some of my students are required to memorize this, some are not. So memorizing it, I've been teaching this for 14 years now. At least more than that, really. And I still look it up every time just to make sure I'm not like missing a negative somewhere or missing any little piece of it. So we see all of these A's, B's, and C's in this formula. So let me show you what that means. The A's, B's, and C's come from the coefficients of the x terms and the x squared terms and the constant terms. So for quadratic formula, you do want your trinomial to be set up with all of your terms over here and set equal to 0 on the other side. So since a x squared does not have, we don't see a coefficient, it's an understood 1. So that means a equals 1. Our coefficient here is 4, so b equals 4. And then our constant is 3, so c equals 3. Now, all of these are positive, so I didn't have to worry about negatives or positives or anything like that. But if you do, we'll get down to this one where we have minus 20. That is going to be a negative 20 for our c term down here. And now we just substitute all of those numbers into this formula and then solve. Sounds so easy, right? All right, so negative 4 is our negative b, plus minus, there's that plus minus in front of our square root, just so, again, we are solving for an equation, x equals all of this. So since we're solving, we want that plus minus in front of our square root. B is 4, so we're going to have 4 squared minus 4 times a, which is 1, times c, which is 3. And all of that is going to be over 2 times a, which is 1. So that is how you substitute in all of our numbers. Now, we are going to follow order of operations to simplify all of this. And we want to go ahead and do what's inside the square root first. And then we follow order of operations inside there. So what we're going to get is 4 squared is 16. And then minus 4 times 1 times 3 is 12. And 16 minus 12 equals 4. So let me just rewrite this just to simplify it. X equals negative 4 plus minus the square root of 4, because that's what we got up here, over, and then 2 times 1 is 2. Now, luckily for us, 4 is a perfect square, so we can go ahead and take this square. So that's going to equal -4 plus or minus 2 over 2. And we are following order of operations still. However, this is the part where we need to split this up into two separate problems because remember that plus minus represents two different numbers. That's saying that, whoops, sorry, that's saying that this 2 is a positive 2 or it could be a negative 2. So we need to split that up into two separate problems. So I'm going to write -4 plus 2 over 2 and then -4 minus 2 over 2 and solve each of those. So let's start with this one at the top. -4 plus 2 gives us -2 over 2, and then -2 over 2 is -1. So that's one of our solutions. And then down here, -4 minus 2 is -6 over 2, and then -6 divided by 2 is -3. So that's the other solution. So to wrap this up, x would equal -1 or x would equal -3. There are two solutions for this equation. All right, let's see what we've got for problem number 6. Okay. So again, we've got our A is 2, B is 3, and C is -20. So our equation is, let's see, where did I write this before? I just did it underneath. Okay. Is negative b, which is -3, plus minus the square root of b squared. So that's 3 squared minus 4 times a, which is 2, times c, which is -20. What happened to my 0 here? Did I accidentally erase that? Sorry, that should have been a -20 right there. All over 2 times a, which is 2. All right, so again, we're going to do, this is called the discriminant. We're going to do all of this inside the radical first. So I like to just kind of write it out to the side, and that way I don't have to rewrite the whole thing until I figure out what this is equal to inside of here. So 3 squared is 9. And then we've got, you can consider this a -4 when you're multiplying if that's helpful for you. Or we can write minus, and then if our number when we multiply all of this is negative, then we can just turn that into a plus, which is what's going to happen here. So what I typically do is I just look and I see, okay, well, I've got two negatives. I know those are going to cancel out and make it plus. So now I just have to worry about the multiplication part. So 2 times 20 is 40, and then 40 times 4 is 160. So then 9 plus 160 is 169. So then let's rewrite that. -3 plus minus the square root of 169 over, and then 2 times 2 is 4. All right, 169 is a perfect square, so that equals 13. So let's rewrite this again. -3 plus minus 13 over 4. And now, again, this is where we split it up into two separate problems. And we do -3 plus 13 over 4 and -3 minus 13 over 4. Let's see what we get. So -3 plus 13 is 10, positive 10 over 4. This isn't going to go in evenly, so I'm just going to simplify and leave it as an improper fraction. So that's going to give us 5 over 2. And then -13, why do I keep saying -13 for the first number? -3 minus 13 is -16 over 4. And then -16 is divisible by 4, so that's going to give us -4. So our two solutions, x equals 5 over 2 or x equals -4. Great. All right, let's do this last problem. I know I'm trying to keep this at 45 minutes-ish, but I do want to do this last problem because I think it is going to be a little bit different than the problems that we've done so far. So let's go ahead and label our A is 2, B is -7, and C is negative. Oh my goodness. I almost didn't do this step. We don't want this -10 right here. We want it to be equal to 0. So we are going to add 10 to both sides of the equation, giving us 2m squared minus 7m minus 3 equals 0. Okay. I didn't do that on the last one, did I? Okay, good. Whew. Sometimes I just get going on these and sorry, my apologies. Teachers can mess up too, guys. All right. So anyways, let's go ahead and now we can label our A as 2, B is -7, and C is -3. All right. Now we can go ahead and sub all of those into our equation. So negative B is our equation, right? Let's just take a quick peek back at that. Negative B is that first term in the numerator, but our B term is already negative. So that means it's just going to switch the sign. So instead of -7, we're going to have +7 plus minus the square root of -7 squared. I did put this in parentheses just to remember. I don't want that negative to get confusing because it is going to be -7 times -7 minus 4 times A, which is 2, times C, which is -3, all over 2 times A, which is 2. All right, let's go ahead and solve what's inside that radical. So a -7 squared is 49, positive 49. I see my two minuses are going to cancel out, so I'm just going to go ahead and write a plus. And then 4 times 2 is 12. Sorry, 4 times 2 is 8, and then 8 times 3 is 24. So let's see, 49 plus 24 is 60, 73. Yeah, 73. All right, so then let's rewrite this. 7 plus minus the square root of 73 over 4. Now, with this problem, 73 is not a perfect square. I believe it's a prime number too. I do not have all of my prime numbers memorized. I know some people can do that. I don't know. That's just not me. But if we could simplify this, we would, but I don't think we can. So this is really it. And leaving it in this form is okay. We do want to say x equals that. Leaving it in this form is okay. You do not have to write it as two separate problems. The only time that you would want to separate it is in like the first two problems that we did where we do have to actually like continue solving and we get down to a number or a fraction or something when the square root is a perfect square. The other times might be if you could do any simplifying with the numerators and denominator. But in this case, that is where we're at. So that is going to be it for that one. All right. Well, let's see. Let's go back up here. All right. Thanks so much for joining me tonight. I hope that this was helpful for you. I have really been enjoying doing these live streams. So if you like them too, please let me know. If you're watching the replay later, then please let me know if you like this kind of format. I think it's kind of interesting. I am going to be adding in some SAT preps because I know that March test is coming up pretty soon. I want to say it's like March 10th or something like that. So I'm going to be going over, we'll probably kind of switch gears pretty soon here next week and just go over some SAT and PSAT for my pre-algebra students. Just some of the sample problems that they have you know, hopefully help some people get a little bit more of a just some extra practice on that SAT because I know that is kind of a big one for a lot of students. All right. Oh, hey Laura, I just saw your comment. Thanks so much for commenting. I don't know if it's like a really like a lot of a lag here, but it feels like that comment came through a while ago. So I'm sorry I didn't see that until now. All right. Well, take care, guys, and I'll see you next week. Bye.